All right, so we have sine, cosine, and tangent, and then we have inverse functions. So I want you guys to start with this right triangle. All right, right triangle trig. So we only do these right triangle trigs with right triangles. So we have to understand what side is what. So if we're talking about angle B, okay, so angle B is right here. There are three sides to the triangle. We have the hypotenuse. Now, the hypotenuse always stays the hypotenuse. How do we know that a certain side of the triangle is the hypotenuse, you guys? It's the longest side. What else, Ian? It's opposite from the 90-degree angle, okay? Longest side and opposite from the 90-degree angle. So the hypotenuse stays the same no matter what. These two switch depending on which angle we're talking about. If I'm talking about angle B, then the side over here is opposite angle B. That makes sense, okay? And the side down here is adjacent to angle B, meaning next to. All right? Let's just draw another triangle right next to it. Whoops. Okay, this is still the hypotenuse. Let's say I labeled this angle A on this side. Okay, so if the angle we're talking about is here, then the side down here would be opposite, and the side over here would be adjacent, next to the angle that we're talking about. Okay, so the only two that switch are opposite and adjacent depending on which angle. Hypotenuse is always hypotenuse. Oh, magical. Okay, sine, cosine, and tangent. I'm so good I don't even have to use my slides. Okay. So, SOHCAHTOA. We need to memorize SOHCAHTOA. This was an Indian guy, friends with Sacagawea back in the day. I'm kidding. Okay, so anyways, sine is equal to opposite over hypotenuse. All right, so that's how we memorize this. SOHCAHTOA. You want to be able to write that out. So you know sine is always equal to the opposite side over the hypotenuse side. All right, and then cosine is equal to adjacent over hypotenuse. So that's the ka. So ka. And then we have TOA. So tangent is always equal to opposite over adjacent. This is something you just want to write on your problem set, like often, SOHCAHTOA, and you want to be able to spell it right. Okay? So you know what you're doing. So find C using right triangle trig. So we're actually going to find angle C in the triangle using trigonometry. They're telling us which one to use. We're going to actually find sine C. By the way, that is not sin. Okay? This is called sine. So sine of C is equal to, well, C is this angle here. So we need to be able to determine which ones are all the sides. So Leo, which side is the hypotenuse? Yes, the hypotenuse is 7.52. Angela, which side is opposite of C? Good. 3.61 is the opposite side, which means that 6.60 is the adjacent side. All right. So according to SOHCAHTOA, we are using sine equals opposite over hypotenuse. All right, which side is opposite? We just labeled it 3.61. Okay, divided by the hypotenuse, which we just labeled as 7.52. So sine of C is equal to, and we're actually not solving for the angle in this problem, we're just finding sine of C. So sine of C is equal to that decimal divided by that decimal, which we can go ahead and find. Sometimes we just leave these as fractions, but if you have decimals, that's weird. So let's go ahead and figure out what decimal answer that is. Anybody got it for me? Sydney? So if we round to 3 decimal places, okay, sine of C is equal to that lovely decimal. All right, find cosine of D, cosine D. So we have a new triangle. And we're talking about the same angle down here. So I still know that 4.76 is the hypotenuse. I still know that opposite to angle D is 3.08. And down here at the bottom is the adjacent side. So according to TOA, we're going to find cosine D, right? So cosine is what over what? Adjacent over hypotenuse. So my fraction is going to be A over H. So 3.63 divided by 4.76. Okay. And somebody on their calculator round that to 3 decimal places like we always do and tell me what answer that is. Sydney? Okay, awesome. And we have the angle still in the same spot, and this time we're going to find the tangent. So we did the sine, we did the cosine, now we're going to find the tangent. We can label these all the same. Okay, opposite, adjacent. So tangent E is always equal to opposite over adjacent because of TOA. All right, so tangent TOA is always opposite over adjacent. So tangent of the angle E is equal to opposite, which is 8.73, over the adjacent side, which is 11.3. And we plug that into our calculator. Dana, did you get it? You guys agree? Okay. Leo. Nope, not until we solve for the angle, which we will be doing at the end, and then yes, you will. We're not actually finding an angle, we're just finding tangent of the angle. Uh-oh. Okay, let's change our settings if we want to actually find the angle, okay? So on the Inspire, okay, we're going to go to settings, so let's find it on the Inspire. Hold on, let me get my Inspire. All right, so I have settings here. I went to the home page. Boom. Oh, turn my smart ink off. I would like to click. And settings. Okay, good. And then we go to document settings, okay? And notice it says right here the angle. So we're talking about the angles in the triangle, and we want to change it to degree mode, okay? So switch it so it's degree mode. Good. If it's already in degree mode, great. Okay, then you have to go to make default, all right? You can tab to make default, or I think you could arrow until you get there, and then press OK, and we should now be in degree mode. We want to check it. Yep, it stayed in degree mode. Okay, and now I want to go back to calculate. Okay, if you have the 84, does anyone in here have the 84? Or 83. Everyone has Inspires. Oh, good. Thanks, first hour. All right. So, using a calculator. These are going to be super easy. We're just going to plug them in. We just have to find where the trig buttons are. Okay? So, I have 3 cosine 45.6. So, I'm going to type in a 3. Then we need to find cosine. See this trig button here? Press it. Okay? Trig button right there. And arrow over, so we have cosine. Don't use inverse cosine for this. We want the regular cosine first. And then, okay, and then there's 45.6. Okay, and press enter. And we're going to round it to 3 decimal places. It was just a baby, but gross. Okay. So 2.099 is the answer. Whoops. Okay, the answer is not in degrees. We plugged in a degrees right here. All right, did anybody not get this answer? Raise your hand so I can come and help you once I pause this. Cool. We're good on that. All right. 2 sine 25. So we go back to our calculator and we plug it in. 2, go to your trig button right here, and then sine, and then 25. Enter. Okay, so 0.845. Round it to 3 decimal places. And that's easy enough, right? Calculator skills there. All right, inverse trig. So this is like one step harder. We're actually going to find the angle. So on the first slide, you guys, on the notes, we were finding the sine of the angle. Now we're going to solve for the actual angle. So find an angle whose tangent is. So I want an angle, and so we use tangent theta. So this little 0 with a tail, have you guys seen theta? That's typically when we're solving for any kind of angle, we use the theta. So find an angle whose tangent is 0.405. So you set it up like that. Okay, tangent theta has to equal that. Now I want to find theta. What is the angle? We want to get rid of this tangent and just find theta. So what we can actually do is take the inverse of both sides. Okay? So what happens is this cancels that tangent out, and now my theta is actually equal to inverse tangent of 0.405, which is a lovely button on our calculator. We can plug it in. Okay, so we take the inverse tangent of both sides. So let's go to our calculators and go to the trig button and go to tangent and then go down to this little inverse tangent, okay? So tangent with a little -1 means inverse. And then it was 0.405, right? Or 0.405. Okay. So now what I did is I just found the angle instead, and I got the theta. So now I got 22.048, so we can round it correctly. So theta is equal to 22.048. And guess what we need on our answer? Good. This is where we need the degree sign when you solve for the angle. Let's try one more. Find an angle whose sine is 0.0794. So we set it up. Sine of some angle is equal to 0.0794. Okay, we have to take the inverse of both sides. And I do need to see that this sign is in the front of the decimal, or you can rewrite it like that, because we're plugging it into the function, the inverse sine function. And plug it into our calculator. So again, trig, sine with the little -1 guy means inverse sine. And then we're going to plug in the decimal 0.709. Was that it, you guys? I think that's the same, right? Oh, 0.794. Okay, you guys got it. 0.794. So much harder on this thing. All right, 4.554 if we round to 3 decimal places, which you should always do. 4.554 degrees, so theta is equal to that. Questions? Ooh. Let's do one more. All right. So we're going to sketch a right triangle that has theta as one of the acute angles. Find a value for the 2 missing trig functions. So if we know sine of theta, you guys, what are the 2 missing trig functions? Yeah, you guys know this. We just learned some new vocab, right? Yeah, it's cosine, but if you say cos, you can, but it's weird. All right, and then tangent theta. So we want to find cosine theta and tangent theta, and the one they give you sets up the triangle, okay? So what do we know sine theta is equal to based on our SOHCAHTOA friend? Opposite over hypotenuse, all right? So we know that sine of any angle is always equal to opposite over hypotenuse. So opposite the angle has to be 8, and the hypotenuse has to be 17. So we're just going to draw a right triangle. Is it going to be perfect? No. So draw any right triangle. And you can label either angle theta to get this right. I'm going to pick this one on the bottom. And so this side right here has to be the hypotenuse. So since this is the hypotenuse, what can I label this side according to this fraction? 17, because it's in the denominator. And sine of anything's opposite over hypotenuse. So 8 is always opposite of the angle. So if my angle's here, then the opposite side is here. And so I can label this side 8. Now, in order to find cosine and tangent, I have to know the adjacent side. Since it's a right triangle, do we know how to find the third side? Yes. All right. So let's label this the adjacent side, because that's what we're trying to find. And let's do the Pythagorean theorem to find it. So a squared plus 8 squared equals 17 squared. You guys solve for a for me. 15. Awesome. So we get 15 for a based on the Pythagorean theorem. Now we can find cosine and tangent. So cosine is always equal to adjacent over hypotenuse. What's adjacent? 15. What's hypotenuse? All right, so there's cosine theta. Do not solve for the angle on this. We're just finding the missing trig functions. The cosine of it's 15 over 17, okay? And then the tangent is opposite over adjacent. So which side's opposite? 8. Which side's adjacent? 15. So we found the missing two trig functions, okay? Now we're good.